So we're going to start our 3D solids unit. What's 3D mean? 3 dimensions. And you can call them whatever you want, but we usually call them length and width and height, something along those lines. Okay? And so within all the solid things that there exists in the entire universe, we have things called polyhedrons. Polyhedrons are just a solid that is bounded by polygons. So you take a bunch of polygons and stick them together and you have made a polyhedron. And there are lots of different ways to make polyhedrons. Just gonna get it. Okay. So polyhedrons are just your flat surfaces that we did in the last unit. So it could be made up of triangles. This would be a polyhedron. What do you usually call that?
Pyramid.
A pyramid of some kind. But you could also have something like this. It's also made of triangles. But is it a pyramid? No. This is a gyro-elongated pentagonal bipyramid. Also known as an icosahedron or a D20. Okay? But it's still just, it's a solid. It's bounded by polygons. That's all it is. Oh, there they are. Is this a polyhedron?
Yes.
Yeah. Is it three-dimensional?
Yes.
Is it bounded by polygons?
Yes.
Yeah. So see? Is this a polyhedron?
No.
But it's a three-dimensional solid.
But it's not a polygon.
Oh, circles aren't polygons?
No.
No, they're not. And so this would not get to be a polyhedron. It is a three-dimensional solid, but it's not technically a polyhedron, but don't worry about it. We'll play with them too. Okay? And so the parts, let's start learning the anatomy of polyhedra here. All these flat polygons get names. All the flat polygon surfaces on a polyhedron are called faces, because you can draw cute little faces on them. So this top little rectangle guy is a face, and this front, ooh, what is this guy? Trapezoid, that's a face. Okay, those are faces, the polygons are. How would you describe an edge? What do you think an edge is?
Where two faces meet?
It's where two faces intersect. So it's a segment where two faces intersect. And I'm just going to use the intersect symbol because I'm lazy. What about a vertex? What is a vertex going to be then? Have you done one already? Okay, go for it.
A place where two segments intersect.
And what kind of object is that place?
A point.
It's a point. So vertex is a point where edges, that's an S, intersect. So vertices are points, edges are segments, faces are polygons. And you've learned how to use all of those over the course of this entire year, which is why only now can we come together and do three-dimensional stuff, because you have to learn how to do all those other things first. Okay? So, there are plenty of types of solids. In this unit, we're only going to focus on 2 types. Okay? We've got things that are polyhedra and things that are not polyhedra. We're going to focus on mostly the polyhedra things. There are 2 types we're going to do. We're going to have prisms and we're going to have pyramids. You ever stop to think about what makes a pyramid a pyramid? What makes a pyramid be a pyramid? If you had to describe to someone what a pyramid is, how they would build one, what would you do?
4 triangles laying on top of each other.
So this is the only kind of pyramid. So this isn't a pyramid then?
More than 2 triangles.
Okay. So what you need is you need something on the bottom. Guess what we're going to call it? A base. And it's got to be a polygon. So you have one, that's supposed to be a P, polygon base. Okay, so there it is. Which particular polygon does this one have as its base? A square. What polygon does this one have as a base? Has a triangle. Okay, and then what forms the rest of the pyramid? Yes?
The other triangles, and so all
Okay,
the faces.
and so then it has triangular, and those are called lateral faces or side faces, or you can just call them plain faces. But sometimes saying lateral helps you distinguish them from the face that is called the base. Because a base is a face. It's just the special one that can be any polygon, whereas all the other ones have to be triangles. Now, does this polygon on the bottom have to be a regular polygon?
Yes.
No. Could I draw some goofy shape like this and then make triangles that go all the way up to a point? It'd be really goofy looking, but it's possible. You can make a pyramid out of any old goofy polygon you want. We don't like those ones though. But just be aware that they do exist, okay? So what makes a prism different from a pyramid? It has 2 bases, as a matter of fact. So it has 2 congruent parallel polygon bases. Sure. So I've got this one on top that is congruent and parallel to that one on bottom. And I tried to color it in, that didn't show it very well. Let's see if this color shows up better. That's a little bit better. Okay? So I've got my bases. They have to be congruent and parallel. So if I tell you it's a prism, you've got to find the two faces that are parallel and congruent to know which ones are the bases. Okay? Then what's the rest of it made out of then? I found my 2 bases. What are the rest of those lateral faces made of?
Polygons.
Any old polygon? I could put triangles here. If I put triangles there, wouldn't they come to a point to make a pyramid? So what do these sides have to be?
Parallelogram.
Parallelograms. Specifically for us, we're always going to use rectangles. Okay? Because we want all of our prisms to be right prisms, to be standing straight up and not be slanted. Okay? And so it's the congruent, not congruent, sorry, I was looking at the wrong thing. It's just rectangular faces. Faces. Not faced. Faces. How many faces along the sides will you always have?
4.
It'll be the same number as whatever your base is. Because look down here. Here's a prism. What shape are its bases? There's a pentagon. There's a pentagon. So we know this is a prism. What kind of prism should we call it? Pentagonal or pentagonal. Okay. How many bases does a prism always have? 2. How many lateral faces will there be if it's pentagonal? How many of these rectangles? There will be 5 rectangles moving up and down the sides. There will always be that many sides. So to classify it, that means to name it. You're going to, figure out, by the shape of the base and what type it is. So is it a prism? Is it a pyramid? Etc., etc., etc. And so this one you said its base was a pentagon, so it was pentagonal. And since it had two congruent parallel bases, you said it was a prism. Okay? So talk amongst yourselves. I'm going to give you about 30 seconds. Figure out the names for these guys. I will give candy to the entire table if you can get the different names right.
Girl, move your hand.
Which one? What?
Move.
Are there different types of pyramids, or is it just?
Okay, shh. So on this guy, okay, well, Maggie, what are you guys calling this guy?
Rectangular.
So you say it's rectangular? Let's see if I can find two congruent parallel bases. Well, let's see, this has two congruent here and two congruent here, two congruent here, yeah, those rectangles definitely look congruent and parallel, so yes, I will call this a rectangular prism. Okay, y'all go get your candy and now you're done giving us names. Okay, this next one, Claire.
Hexagonal pyramid.
This is a hexagonal, because it has a hexagon base, pyramid. What the heck is this? This isn't a polyhedron? It's not a round pyramid? It looks like a round pyramid, but we don't want to mix it up with a pyramid is actually made of polygons. So instead of calling it a round pyramid, you call it a cone. And you can put ice cream on it if you want, or you can give it a little party hat poof, whatever. But it's a cone. Okay, get stuff for your table. Yes, Matthew.
Triangular pyramid?
This one is a triangular pyramid.
What's technically?
Okay? Notice something. Shh. What does a cylinder? It's not a polyhedron. Which of these two things does it seem to be the most like? Yeah, go ahead. What does this cylinder seem to be most like?
Prism?
Yeah, it's kind of like a round prism, except prisms have to have polygon bases. And since this is a circle, we don't call it a round prism, we call it a cylinder. But it acts just like a prism. Cylinders act just like prisms. Okay? What is a cone the most like? It's most like a pyramid. It's like a round pyramid. But again, pyramids have to be made out of polygons. Is a circle a polygon? No. So you can't call it that. You call it a cone, but it acts just like a pyramid. And then we've got the sphere, and we're going to ignore him for a bit. Okay? Can you two ever can tell me out of the blue what the definition of a regular polyhedron would be? What do you think it is?
Congruent bases and congruent bases.
Okay.
Polygon with, or a polyhedron with congruent bases and congruent bases.
Close. Everything has to be congruent, but you left out an important thing. No?
Congruent vertexes.
Okay, you're all very close. It is a polyhedron with all the faces are congruent. They are also regular polygons. Because do we want a bunch of congruent rectangles? Congruent rectangles would not make a regular polyhedron. Congruent rectangles would make a box.
What does that say, regular?
Polygons? And so you've got to be careful, okay? So what is the smallest, fewest number of sides a regular polygon can have? One side? What does a one-sided polygon look? We don't have one gons. What's the smallest number of sides a regular polygon can have?
3.
3. What do we call that?
Triangle.
Wrong.
Regular triangle.
Equilateral triangle. And if you put a whole bunch of equilateral triangles together, you have a regular polyhedron. But wait, here are also a bunch of equilateral triangles put together. And oh, here also are a bunch of equilateral triangles put together. Those are all regular polyhedra made out of triangles. What's the next kind of regular polygon you can make past a triangle? A square. So if you put all squares, what do you have?
Cube.
A cube. And this is the most common one. The cube is the most famous. Because every side is a congruent regular quadrilateral. It's all squares. What's the next thing you can make? After we did regular triangles, regular quadrilaterals, regular pentagons. Kites can't be regular because they automatically don't have all congruent sides. They have 2 sets of adjacent. Could you do pentagons to make a regular polyhedron?
Yes.
Yeah, this is a dodecahedron, a 12-gon, also known as a D12. Okay? And it's made of regular, what are those?
Pentagon.
Pentagons. You ever seen a soccer ball? That is not a regular polyhedron because it has both hexagons and pentagons. And hexagons and pentagons aren't the same shape. Okay? We're not going to get into these too much. We just want you to know they exist. Because they're fun to play with. Who doesn't want to play with a gyro elongated pentagonal bipyramid? You ever seen Vsauce? Hey Vsauce, Michael here? He's got a great video of building different polyhedra out of regular shapes. It's very fun. And so of course during COVID, guess what my girls did? They got a bunch of them and built them because of course they did. They're weird. Okay? Have you ever done a cross section of something? What's a cross section of something? Well, you slice it open, right? You ever had anybody in here ever had an MRI? You were cross-sectioned. MRIs work by taking thousands of cross-sections and then sticking them all together to get an image of your innards. And so all a cross-section is the intersection of a plane with some kind of solid. And where they intersect is going to draw a shape on that plane. What shape appears on my plane when I cut off the corner of that cube? A triangle. Your cross-section here would be a triangle. So all the cross-section is the part that shows up when you slice something. So if I chop your head off and make a cross-section, what will that be close to being?
Sphere.
Sphere? It's got to be on a plane though. Kind of like a circle or an oval or some kind of goofy thing. What would be the cross-section if we just do a cone?
A circle.
Well, if we do it parallel to the bottom, its cross-section would be a circle. Next year in Algebra 2, you're going to tip that plane and cut it this way and make a shape called an ellipse. The conic section. Or you'll cut it parallel to the base and make a parabola. Or you'll cut it perpendicular to the base and make a hyperbola. So you will do these next year with cones. They'll be called conic sections. You'll hate them. Congratulations. What shape is this cross section when I chop off this guy? That one's a hexagon. And some people have a really easy time visualizing 3D. And some people just don't. And so it's okay if it's not your strong suit. Don't go into geography. because you have to be good with shapes and geography, because you have to be able to do elevations and cross sections and stuff like that. Or architecture. And so the thing, there are two ways you can measure three-dimensional solids. Okay? You can find their surface area and you can find their volume. Someone tell me what surface area is. The name gives it away.
The area of all the surfaces.
It's the area of all the surfaces. What are the surfaces on a polyhedron?
The faces and bases.
Which are made of polygons. So surface area is going to be the area, hey, okay, so it's the total area of all the faces, including the bases. Yeah.
On the first page, were we supposed to do the, viewers term?
Oh, I forgot that. I'll get back to it. Thank you. I'll get to it on the next page. It ties really well into page 3. Okay? Thank you for reminding me. Okay? Oh, wait. How do I measure area? What is area measuring? When you find area, what are you finding? Well, yeah, but what is area?
How much space is inside?
How do you measure space on an area? What are you counting? Squares. So it's the number of square units. And that's what we were doing in our last one. You had square inches, square miles, square furlongs, square millimeters, whatever. You are literally counting the number of squares on all these surfaces. Okay? And so for a prism, it's going to be with your two congruent parallel faces that are called bases. Okay? And they've got to be congruent and parallel and stuff. You've got to find the area of those two base faces, as well as the faces that wrap around. They're called lateral faces. Did any of you in a previous past existence that you've tried to forget ever have to do surface area and lateral surface area and total surface area? Some of you have seen a little bit of this before. We're going to just focus on total surface area. We're always going to include the bases in there, okay? And so how do I get the surface area of a thing then? If I want to know what all the surfaces are on this, how am I going to do it? What do I find the areas of? Go ahead.
I was just going to say formula.
Yeah, but that doesn't tell me anything. That's just a bunch of letters. I need words. If I've got this prism, what kind of prism is this one, y'all? This one's hexagonal. It's a hexagonal prism. Okay? And I want to find the total surface area. Well, what will I need to find the area of if it's a prism? What shape is this? A hexagonal, and it's one of the bases. Oh, but wait, how many bases does a prism have? 2. So if I want to find the surface area, I need to do the area of the base, which always gets a big B, and I need to do it twice, because they're going to be congruent. Notice that this big B stands for the area of a base of the prism. Big B is area of base. What's little b? Little b, if I'm doing little b, that's like when you do base times height of the triangle. That's what little b is talking about, is a length of a base. Big B is area of a base. And so the same word base is being used in 2 different ways. We've got the length of an edge, or you've got an area of a surface. And so you're going to have to keep straight what kind of base you're talking about when you talk about bases now. And it's going to get confusing really fast if you're one of those people who never labels anything on your test, hint, hint, wink, wink, nod, nod, because then you're going to mix it up. Okay? So keep them straight. So I've got to find, okay, so here now I found the area of my two bases. There they are. But now I have to have the area of all these rectangles. Do you want to have to find 6 rectangular faces? Not really, because you're kind of lazy, aren't you? Because you're mathematicians. So how could I find the area of all of it at once? Well, what shape is this lateral surface? It's a giant rectangle. It's a giant rectangle. How to find the area of a rectangle? How do I find the area of a rectangle? It's length times width, right? Well, there's a lot of murmuring going on. What is the length of this rectangle? It is just the height of my prism, right here. Okay? And so I'm going to take that height. Well, what is the width of this whole thing? It's the distance around the base, because I can take this and wrap it all the way around, can't I? So the length of this rectangle is just the distance around the base. Okay? And so my formula says, okay, I have to find 2 area of the bases, and then I have to do the perimeter times the height. And then you have your surface area without having to find a whole bunch of individual little rectangles. Because especially, what if all the rectangles are not the same size? What shape is this? Triangular prism. See, the base on top and the base on bottom are triangles, and then these long, skinny rectangles are the lateral faces. Is this rectangle here the same size as this rectangle here?
No.
No. This one's little. This one's the long and skinny. And since it's a right triangle, the hypotenuse one's going to be a different size as well. So rather than having to find 3 rectangles, doing perimeter times height just turns them all into one big unfolded rectangle. And this is why people who can do topology and 3D geometry, I'm very impressed with them, because I have to wrap my brain around this, and my brain doesn't do this super great. Okay? And so I have to do the perimeter of the base. What is H? Height of what? Of the prism. And the height of the prism is always going to be the distance between the bases. So this distance between the base on top and the base on bottom is always called your height. Okay? And so here is my height. Well, what if I lay it on its side? Did my height change? No, I just turned it sideways. The height is always going to be the distance between these 2 congruent bases. So the height might be up and down. The height might be sideways. But it's always the distance between the 2 parallel things. Okay? What about a cylinder? Well, wait, isn't a cylinder just kind of a round prism? So how do you think I'm going to find its surface area? Well, how many bases does it have? 2. So I'm going to have to find the area of 2 bases. What about the lateral surface? What shape is it? It's also a rectangle. What is the length of that rectangle? The perimeter of the circle. But what do we call the perimeter of a circle? Circumference. And then times the height to make a rectangle. Are they basically the same formula? we just expect you to know that perimeter for a circle is called circumference. And so that's why if you look over on the board, where I've got surface area of prisms and cylinders here, I just have one formula written down with perimeter times height. Because if you know that perimeter and circumference are the same thing, you don't have to memorize two formulas. Do you want to memorize that formula? Or would you rather me leave it written on the board?
On the board.
I can leave it written on the board, but then you'll have, what will you do when you go home? You might want to use your notes. Would it be helpful to just understand how surface area works? And know that it's the area of these two bases and the area of this rectangle that has perimeter and height? That could be helpful in figuring out the formulas. That's how I have to do it. I don't memorize worth beads. But I can understand how things fit together and create the formulas in my head. And that's pretty much what I do every time. Okay? All right. So, let's make the formula then. If I had to do the surface area of a cylinder, what would be the area of the base of my cylinder? How do I get the area of a circle? That's going to be pi r squared. So you would have to take this basic formula and do formula inception and put a formula inside the formula. Plus, how do I get circumference? What's that?
Is it 2 pi r?
I don't know, is it? Okay, somebody else agrees with you. So 2 pi r, and then times your height. So now I've taken the same old formula I had up here, and now I've turned it into the custom one for a cylinder. And C is circumference, H is height, B is still the area of the base. And you already know how to do those. That's not so bad, is it? Cool. What's volume? It's not how loud things are. That's a different kind of volume. Go to physics for that kind of volume. Okay? What's volume in geometry?
How much?
Oh, I'm thinking I don't know.
Well, yeah, it's the amount of space in something, but how do you measure space in 3D? Seth? That's a calculation for it. What do we measure with though?
Volume?
I measure length with segments. Cubes. Volume is literally counting the number of cubes. When you were a kid in your elementary, did you ever use the tiny counting cubes?
Yeah.
For everything?
All the time.
Did you know that they were always 1 centimeter cubed?
Yes.
They were 1 centimeter by 1 centimeter. Oh, they were 1 cubic centimeter. 1 cc, which is what they use in medicine to measure how much meds they give you. Because cc's, cubic centimeters, are also equal to milliliters. 1 cubic centimeter holds a milliliter. You didn't want to know that, but you just did. So volume is the number of cubic units contained inside a solid. Okay? So like if you filled it up with water and wanted to know, how much water is this? You could pour that water out into little tiny cubes and see how many of those cubes it is. Okay? That's what you're counting when you count volume, is the number of cubes it is. You can measure volume of air. This room has a volume. You have a volume. In fact, most adult humans have a certain volume of blood that they have. And then that's converted into pints, usually, how many pints of blood you can bleed out before you're dead, or whatever. Okay? And so it's always cubic units, which is going to be units with a cube, power 3 on it. Or you might say cubic whatever. You might say cubic inches or cubic feet or whatever. So you might have inches cubed, you might have centimeters cubed, but centimeters cubes are just cc's. So if you ever watch those medical programs and they say this person needs 700 cc's of something stat, that's cc's, which are also known as milliliters.
Is that something
No, but that'll be a good thing you can use when you get to chemistry and stuff, and you start measuring stuff, and they're like, how big is a cubic centimeter? And you're like, that's a milliliter. That's how they created a milliliter, was they said, okay, we'll call a milliliter the same size as a cubic centimeter, and then we'll make 1,000 of those into one normal size liter. Yeah, you're excited.
We're so much smarter that we just made a bunch of abstract measurements.
Well, the customary system is about 25 different other systems that were all interconnected, that weren't meant to be connected. But they were because Americans were stubborn and wouldn't go to Metro. Okay? But some of the customary units are much more convenient than metric units. I like inches better than centimeters, and I like feet better than decimeters. Okay? Only because you're not used to it. Shh. Decameters are more fun, though. So how do I get volume then for a prism? Well, guess what, guys? A prism is just a stack of bases. A prism is just a stack of bases. Okay? Think about that. Think about a rectangular prism. So a rectangular prism. Shh. What is my base? A rectangle. If I want to know how much this holds, I just need to know how tall the stack is, isn't it?
Yes.
Okay? So if I know how tall the stack of bases is, I can know how much paper is in the prism. This happens to have a rectangle on the bottom. Okay? This has what shape on the bottom?
Hexagon.
That's a hexagon. So if I could just figure out how tall this stack of hexagons is, I would know the volume of this. So what do you think the formula is for volume of a prism?
Area of base.
Area of base, remember that's what big B is. So big B is area of base times
Height.
the height of the prism. And so here, you happen to have a rectangular base. So how would you find the rectangular base on this guy? How would you find the area of a rectangle for this guy? Oh, do you remember from last unit what the formula for the area of a rectangle is?
Length times width.
This would be length times width. So to get my volume, I would have to do the length times the width times the height. Did you know that's where your length width height formula came from back when you were a little kid? It's the area of the base times the height. But is every prism a rectangular prism?
No.
Okay, who needs to move?
Can I go back there?
You can focus. Okay. What shape is this one?
Hexagonal.
It's hexagonal or hexagonal. Okay. So if I wanted to find, oh, that's this guy up here. If I wanted to find the volume of this guy, it would still be the area of the base times the height. But how do I find the area of a hexagon?
AP is the
1/2 AP
What?
times the height. So are those all things we just did in the last unit coming back to haunt you?
yes.
As always, you are never safe. You are never safe in that. The old stuff always comes back. Because if you find the area of this thing, if I make just a little stack of this, will it have very much volume? But if I stack up more and more of those hexagons, it'll give me more volume, right? And the taller it gets, the more volume you have. So, but it all has the same base on the bottom, doesn't it? So if you find the area of that base, then the volume can just be controlled by how high you make it. Okay? And that's why that formula is the formula for the volume. Okay? So what about for a cylinder? What do you think the formula for the volume of a cylinder is? Well, isn't a cylinder just like what?
Prism.
A prism. It's like a round prism. So guess what its formula for volume is?
BH.
Area of base times height. Oh, but wait, this is a circle. So what is my formula for the area of the base of a circle? That's pi r squared. And then you use the height to get the height of your stack. Okay? You cool with those? Are those too bad? If you don't understand them completely, are they written on the board for you? Turn the page. Shh. We're almost done, guys. Yes? We're about to go back to that, okay? But it connects well to this, and so I wanted to get to this. Okay? So all of our 3D shapes we've been using have the same parts, okay? Prisms have what? They have faces, they have edges, and they have vertices. And pyramids have faces and edges and vertices. Okay? They both have the same components to them. And if you go back to page 1 of your notes, you're going to see a little formula that connects all of those together. Okay, that we did not do. Okay? Let's see, where did I put him? Oh, it's this back of this page. Euler's theorem. Now wait, how did I just pronounce that?
Euler.
Euler. Does it look like it should be spelled with an EU? No? But should Kirkendall be spelled with a Y?
No.
Not in English. But guess what? It's not English. Shh. Different languages use different letters for different things. The language that Euler spoke, I believe he was Dutch? And they use different letters to make the sound oi. EU says oi, so this is Euler. His formula says that faces, the number of faces you have, plus the number of vertices you have, should always equal the number of edges you have plus 2. That could be for a prism. That could be for a cone, or not a cone, a pyramid. It could be for goofy gyro elongated pentagonal bipyramid. It doesn't matter what the shape is. If you count up the number of faces, guess how many faces this has?
20.
This has 20. That number, plus the number of vertices, should always equal the number of edges plus 2. You could test it, but you'll get to do that on your homework. He was very smart. He wrote enough books that if you put them side by side, they'd go all the way across the end of this room. Okay? Oh, and he was blind most of that time. Yeah, he's one of those. Okay? Shh. But wait. There's more. Shh. So we have that formula. The faces plus the vertices equals the edges plus 2. But what if you don't know all those things? You can still figure out a lot of them because they're all connected to the base. If you know what shape your base is, you can figure all those numbers out. Okay? And so, let's see. If you know what shape your base is, do you know the number of sides it has?
Yes.
So this base is a hexagon. So how many sides sides does my base have here? It has 6 sides. So if I know the number of faces, so the number of base sides, if I know the number of sides on this, can I figure out the number of faces on my prism? Well, let's see. How many rectangles will there be to go around the hexagon?
6.
So I need to know the number of base sides. Okay, I'm going to get this out of my way. Okay, so that will give me 6 faces that are these rectangles. Is that the total number of faces on my prism? Then there's the 2 bases on the ends. So the total number of faces is always number of base sides plus 2. You just count up this number here. That will tell you the number of lateral faces, and then you add the bases on the end. So what if I told you you had a pentagonal prism? How many sides does the base have here? 5. Plus, how many bases are there? 2. So how many total faces? 7. Okay? Shh! What about edges? Yes, it is. You'll be fine. If I have edges, if I know the number of edges there are, can I figure out the number of edges there are if I know how many sides the base has? Well, let's think about it for a minute. If I know, somebody give me a number of sides for a base.
20.
A little bit smaller.
10.
Let's go 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 sides on the bottom. Oh wow, how many edges is that of my prism? 10. 10 edges. What about on the other base? How many will there be? There'll be 10. How many edges will it take to connect the 2 bases together? It'll take 10 more. How many times did I use that number?
3.
3. So the number of edges is going to always be the number of base sides times 3. So if I had 10 sides on my base, I will have how many edges? 30. Because there will be 10 making the bottom decagon, 10 making the top decagon, and 10 edges connecting. Okay? What about the number of vertices? If I know how many sides my base has, can I figure out how many vertices will be on my prism? Well, let's think about it for a minute. Okay? If I knew my base was a hexagon, how many vertices will there be for a hexagon at the base? If I have a hexagon base, how many vertices are there? 6. And how many will there be at the top?
6.
So I've got 6 and 6. Connecting them, does that make new vertices? No, it was just connecting vertices that were already there. So how many times did I use my base number of sides here?
2.
Just 2. I don't have those formulas memorized, but I can figure them out in a hurry by stopping and thinking about if I needed to draw it, what would I draw? And you can do that too. I'm not going to stop you. And so the kind of problems you're going to see with these is, okay, if I tell you a prism had 9 faces, can you work backward? Can you work backward and figure out how many sides are on the base?
Yes.
Okay, how would I work backward? If a prism has 9 total faces, what can I do to figure out the number of sides? Yeah? Let's take off the 2 bases. will give me how many lateral sides? 7 lateral sides. If I have 7 lateral faces, how many sides have to be on the base? That same number. So it's going to be 7. 7 sides on each base. And you can work it backward to make sure. If I had 7 sides on the base, that would give me 7 rectangular lateral faces plus 2 more bases to give me 9. You can rework them backward to make sure your thinking was right. And I recommend that if you're unsure. So if a prism has 24 vertices, how many faces does it have?
12.
This is a trick question.
No.
Because what does the 24 vertices let you figure out? That you have 12 sides on the base. Is the 12 sides on the base the same as the total number of faces on the prism? No. I would have to take 12 sides on the base and go, okay, once I have the base sides, what do I do to get the total number of faces? Add 2 to get 14. You had it right? Good job. So these aren't just all going to be straightforward. You have to think. And I know some of you are trying to not think as much anymore. Don't worry, your life is going to have you thinking for the rest of it. Just get used to that idea.
Okay, really?
Okay? Shh. Oh, but wait, what about a pyramid? Do pyramids work the same?
Yes.
Really? Cool. Let me get one then. So let's see, I've got this guy here. Oh, where's my other one? There, wait, no. Did I bury my other pyramid? Where did I put my other pyramid? Oh, here he is. So here's some pyramids. So you're telling me that if I want to know the number of faces on this square pyramid, I should count the 4 base sides and then add 2 bases to it? Are there 2 bases on a pyramid?
No.
Oh. So should my number of faces be the number of base sides plus 2? Yeah, if I have 4 sides on my base, how many triangles am I going to form? I'm going to form these 4 triangles. But then I need to count the base as a face, so I need to add 1. Yes?
Does that say plus base, number of base sides?
The number of base sides plus 1. What about the edges? How many edges are there going to be on this thing? Are there going to be edges around the base?
Yes.
Yes, so I'll need to know the number of base sides to get those. So this guy is a square pyramid, so I'd have those 4. Okay, how do I get these edges? How many edges are there going to be going up?
4.
The same number.
So it's base sides.
Number of base sides twice. Because then you'll have the 4 edges along the bottom, and then the 4 that come up to the point at the top. Candy, whoever knows the name for the point at the top of a pyramid?
A vertex.
It's not a vertex.
Main vertex.
Nope. Every predator in the world knows what it's called.
The apex.
Oh, wait.
The apex.
Oh, wait.
Prey.
The apex. This is the apex. Okay? Shh. So, go get it. How many vertices will my pyramid have? Shh.
Plus 1.
How many vertices? How many vertices will there be down at the base?
Base sides.
The same as the number of sides. Then will there be any more vertices on a pyramid?
The apex.
There will be the apex. And so I always have to add 1. So again, you don't have to memorize these. You can think them through and figure them back out if you want. Okay? But they're fun to think about. And it's fun to play with the toys. And it's fun to, do all the stuff where you take them apart. We get to do this tomorrow. We get to do this next class. We're going to take it apart. That'll be fun. Okay? So how many edges does a pentagonal pyramid have then? How many sides does the base have? 5. And then to get edges? Times it by 2, because you have to have the 5 along the bottom and then the 5 that go up to make 10. Okay? Shh. Now, before I turn you loose on the homework, I want to just walk you through some of the thinking and organizing you're going to have to do on these. Okay? So on this first one, I want you to find the total area, that's just what we call surface area, and volume of a cube. I haven't given you volume of a cube. What is a cube? But what shape is a cube? It's a prism. What kind of prism?
Regular.
A square, rectangular prism. So what's my formula going to be for the volume of this guy? It's a prism, so it'll be the area of the base times the height. But then, this is where you have formula inception. How do you get the area of the base if it's a square?
S squared.
Side squared times your height. But wait, if it's a cube, how big is my height? The same as the sides, which will give me what? What's S squared times another S?
Volume.
S
2S.
cubed. Yeah, some of you have forgotten your exponent rules. So the formula for a cube, if you want to learn that it's S third, you can, or you can just use your prism formula. Your prism or prison? Prism formula, whatever. Okay? How are you going to find the surface area of your cube? How do you get surface area of a prism? What's your formula? 2b plus pH. But if it's a cube, how do I get the area of the base? S squared. How do I get the perimeter? How do I get the perimeter of a square?
4S.
4s. And how do I get the height of my cube? It's just s. Well, what's 2 times s squared? 2s squared. What's 4s times s? 4s squared. So your surface area of the cube is just 6s squared. See how I worked out all that algebra? A lot of you lost points on your test because you left stuff looking like this instead of simplifying it down to this. So this is the formula for surface area of a cube. You can memorize it or you can just use your other formula because it's going to get you the same thing. So how am I going to find the total area and volume of a prism whose height is 12 and whose base is a regular hexagon with sides of length 8? Which do you want to tackle first, surface area or volume?
Volume.
Volume. What's my formula for volume?
Base times height.
Hold on. Did I do?
Area.
This is, okay, this is prism. Why did I do volume? It's just base times height? Area of base times height? Oh! What is the area of a base for a hexagon? That's your 1/2 AP formula times your height. What? I heard someone say y is what?
Wait, never mind.
You sure? Because I want to answer. I'd rather you not be confused. Okay? So then you're going to have to come over here and figure out, well, what is the perimeter of my thing? What is the perimeter of a hexagon with side length of 8?
48.
Oh, that's going to be 48, so I can plug that in. Do I know the height of my prism? They told me it was 12. So what am I left having to find? The apothem. So you're going to have to do your whole thing with your central angle and your half angle and your little right triangle. What about surface area? 2b plus perimeter times height. Oh, if I find my base for this one, can't I use the same number here? Whatever that was? Yeah. And this perimeter here is the same as this perimeter here, isn't it?
Yes.
And then my height is still how much? 12. So a lot of these numbers are going to get used over and over again. So if you label everything as you go, if you have found something for this problem, then you can come and use it over here. Or vice versa, because they use a lot of the same stuff, because it's the same ding-dang shape. Okay? Down here, raise your hand when you know what the name of this shape is, but don't say it. Raise your hand when you know what the name of the shape is. Not very many people are raising their hand, I'm worried. Is it a pyramid?
No.
Okay, so now you know it's not a pyramid, so it's probably a prism. So now you've got to look for your two parallel congruent bases and see what they are. Okay? Okay, Alex, what do you think it is?
It's a trapezoid prism.
It's trapezoid, and we see trapezoidal to make it an adjective. Prism. We don't just say trapezoid prism. It's trapezoidal, and yeah, my handwriting's garbage. Trapezoidal prism. And so, when I do my volume, doing area of base times height, what is going to be the formula I put in for that area of a base? The 1/2 B1 plus B2 times the height. Oh, but wait! Which height is this one?
Oh, height of the...
The height of the trapezoid. That height right there. Which height is this one right here?
Height of the prism.
Height of the prism, which is this guy right there. So are you going to have to keep very careful track of what H you're using in which thing?
Yes.
Because we don't make a difference in the formulas, they're just H. And you have to know that when you're doing this formula, the H is the height of the trapezoid, and this H is the height of the prism. So you're going to have to be organized and careful. You can't do the I'm just doing it all in my head crap. Same with surface area. Okay? What shape is this one?
Triangular.
Is it a pyramid?
Triangular.
No. So it must be a triangular prism. And you'll use the same two formulas for surface area and volume. But what is going to be the area of the base here?
1/2 base.
1/2 base times height. Because B is the area of a base, right? My base for this is this triangle on either end. Okay? So just be careful, you guys. I would suggest labeling your stuff as you go and being extremely organized. Okay? And you can use the remainder of the period